I'm Anil Kumar sharing with you a video on probability. This is on request of my subscriber who wants some videos for 11 plus year old students. Now, I've taken up 3 examples here, and in these 3 examples, we'll talk about the concept of organizing and then finding probability. So I don't really have these kinds of videos in my playlist. So let's see, we'll build one. Thanks for the request. The question here is, I have 5 coins in my pocket worth a total of 50 cents. There are no pennies. Guess what the coins are. What is the probability of your guessing the combination of coins if you have only one guess? Now, I'm here in Canada, and the type of coins we have are, let me share that with you first. We have pennies, which are now discontinued, right? And then we have nickels. And then we have dimes. And we have quarters. Okay, we also have $1 and $2 coins. We call them loonies. Is $1, and then we call toonies. Right, so that may not be known to many students worldwide. Pennies is like 1 cent. Nickels is 5 cents. Dimes is 10 cents. Quarters is 25 cents. This is $1, and that is $2, right? So sometimes we put 2 lines here. So these are the coins which we are talking about. In this question, we are saying that we have no pennies, so we are not including pennies here. And the total is 50 cents. 50 cents means we cannot have loonies or toonies. So we have nickels, dimes, and quarters. Perfect. Now the idea is to find probability that a person can guess correctly what coins are in my pocket. So that's very interesting, and I have total of 5 coins. So you can actually pause the video, think about it, and see how it can be answered, right? So we are actually trying to develop a concept for the students in grade 6 to 8 so that they could organize the information and then find the result. That's the whole idea. And I hope it is well taken care of with this example. So what I can do here is I can make a table, right? And then we can work out all possible combinations. So we'll make a table. We could have quarters, so I'll write quarters. Let's write quarters Q. And we could have dimes, let's say D for dimes and N for nickels. So total, let me write total here. Clearly, we need total of 50 cents. So this has to be 50 cents. Now, I could have 2 quarters. Quarters is 25, right? Quarters is 25. Okay, 25. Everything in cents. This is 10 and this is 5. So now you can, everything in cents, okay? Just add the numbers. So if I say 2 quarters, the one possibility is that I could have 2 quarters. So 2 times 25 is 50 cents. If I have 2 quarters, then I do not have any dimes and nickels. Does it make sense to you, right? Is this clear? Perfect. Now, if I have 1 quarter, that means I have 25 cents. To make 50, I could have 2 dimes, right, and 1 nickel. So now I have again 50 cents. Is it okay? So with this combination, I have 50 cents. Okay. So that is with 2 or 1 quarter. So systematically, we're trying to put information in a table, right? So with 1 quarter, I could also have 1 dime. That means I have 25 and 10, 35, 40, 45, 50. That means 3 nickels. Correct? That will also give me 50 cents. Perfect. So you have to be careful when you make this table. It's not that simple, but go slow as I'm moving. Now we have run out of all the options of having quarters, right? So over dimes, but we still could have 1/4, no dimes at all. So we have 25 cents here. To make 25 with nickels, we need 5 of them. That will also make 50 cents. Does make sense to you, right? So still we have 50 cents. So you can see that with each combination, we are trying all possible combinations of dimes and then working out nickels. Correct? Now, so we have run out of this quarters. So let's say 0 quarters now. And if we take only dimes, 50 cents, we can have 5 times 10 is 50, right? So if I have 4 of these, then I have to have 2 of nickels, so to make it 50. Do you see that? And if I have 3 of these, I may have to push this page a bit. Okay, so if I have 3 of these, then I have 30 cents here. To make 20 from nickels, I have to make 4, right? So I have 4. So I have 50 cents total, right? Now one thing you will notice here is very important criteria that I have 5 coins. So what I'm looking for here is number of coins should be 5, right? We are looking for 5 coins. Important, right? So if I count the coins, let's see. So we have 2 quarters, 1 dimes, and no nickel. That means the number of coins is 2 for me. In this combination, I have 1 plus 2, 3 plus 1, 4 coins. In this combination, I have 5 coins. So that seems to be the correct option, correct? Now, in the next combination, I have 1 plus 5, which is 6 coins. Then I have again 5 coins here. So that seems to be the correct option also. Now I have 4 plus 2, which is 6 coins. And then I have 3 plus 4, which is 7 coins. And if I move on, my number of coins will be greater. Do you see that? More and more coins. Now the question is, now look at the question. I have 5 coins in my pocket worth a total of 50 cents. So basically, we have come down to 2 combinations. So one combination which gives you 5 coins is this one. The other combination is this, 5 dimes. So there are only 2 possible combinations which will give me 50 cents with 5 coins. Correct? Now, let us answer these questions. What is the probability of your guessing the combination of coins if you have only one guess? Correct? Now, what is probability? Let's define that first. Now, in probability, we look for 2 things. One is, what are favorable combinations? Favorable number of combinations. Is that okay? And the other one is total number of combinations. In this example, we could write probability for 5 coins, right? Correct guess is there are actually only 2 combinations possible, so that 2 comes here, right? With 5 combinations, there are only 2. And what I could say is select one of them because I have only one guess. So one guess means I could get either 1/4 dimes, so 3 I could say that, or 5 dimes. So that is 50%. So my probability in this case is half. So we could write our answer as the probability is half or 50% times 100 or 50%. Is it okay? So that is how you could answer such questions. They are actually very tricky and difficult, but you need time to organize your data, understand, and then answer. So based on this concept, I have two more questions for you, right? So let me share the questions for you. Now here is the next question. It says, Peter threw 2 darts and hit the dartboard each time. Assume both darts might have hit the same number. So if you throw 2 times, one thing is every time you get a point is based on where it hits. If it is hitting in the center, I mean the inner circle, you get 10 points. Middle circle, you get 5 points. And in the outer circle, you get 2 points. And says every time the dart hits, that means you always get a point. Second, you could hit at the same circle twice also, right? Now the question is, how many outcomes are there? So first question is, how many outcomes are there? And the second one is, what is the probability that his score is less than 10? So that is combination of 2 hits. Perfect. So this is the question for you. You can pause the video, answer, and then look into my suggestions. Now here again, we have 2 hits, right? So we'll make a combination of chart. Now in every hit, you could either get 2 or 5 or 10. So we have these columns in which we'll write 2, 5, and 10. And then we'll just add them up, and then we'll see what is the probability. Is it okay? So let us say this is our first hit. It doesn't really matter first or second, but let's say this is hit 1. Let me call this hit 1, and this is hit number 2. When we write the possible combinations, we should start with one number. Let's say we start with 10, and with 10, what can you get? With 10, the other hit can be 10, and with 10, the other hit can be 5. With 10, the other hit could be 2, right? So with 10, you could have 1, 2, 3 combinations. Now if I take 5, then we could have 5 with 10, which we have already considered, right? So either way. So with 5, you could get 5, and with 5, you could get 2. So we have 2 additional sets of combinations, right? New totals. So here we'll write total. Or score. Is that okay? So the score will be 20 in this first case, 15 here, and 10 plus 2 is 12, 5 plus 5 is 10, like that you get a score. But if I hit 2, then combination with 5 and 10 are already taken care of. So a new combination is 2, 2, which totals to 4. Perfect. So we can now find how many outcomes are there. So there are these many outcomes. That means different scores. So let's write down. When we say number, this is like number of outcomes. So one outcome is a score of 20, the other outcome score of 15, likewise. So we have 1, 2, 3, 4, 5, 6. So we have 6 outcomes. Do you see that? Number of outcomes are 6. A score which could be 4, 7, 10, 12, 15, or 20. So these are the outcomes. Now the question is, what is the probability that his score is less than 10? So out of these, which are less than 10? We are saying less than 10. So there are 2 scores which are less than 10. You should not include 10 because it is less than 10. Perfect. And now the probability will be what? So probability for less than score of 10 is, what are favorable combinations? We have 2, right? But it's the ratio of favorable combinations to total number of combinations. Is that okay? Favorable combinations are 2, and total here is 6. And therefore, probability is 1 out of 3 or 33.3%, right? So it is, so the answer is 1 out of 3 or 1 out of 3 times 100%, which is 33.3%. Does make sense to you, right? So that is how such questions can be asked, right? So let me give you one more question here and treat that as your test question. So this time I'm not going to solve it. It is based on the first question we did. So it says, suppose you have 2 coins in your pocket. So you have only 2 coins. That means now we are thinking about making just 2 columns for the number of coins, right? Suppose you have 2 coins in your pocket. 2 coins can be pennies, nickels, dimes, or quarters. So let me write pennies for P, N for nickels, D for dimes, Q for quarters. How many outcomes are possible? Right? So that is the first question. How many outcomes are possible? That means combination of these, right? How many combinations will add up to 20 cents? That means we have to add and find the total amount also, right? What is the probability of having more than 20 cents? All right? So these are the different questions related, and the idea is you have 2 coins. That means you could have like 2 pennies, right? So we'll say 2 pennies, correct? And then you could have, with a penny, you could have nickel. With a penny, you could have dime. With a penny, you could have quarter. So you got all these combinations with pennies. Do you see that? Now make with nickels. With nickels, pennies are already taken care of. So with nickels, we can have nickels. With nickels, we could have dimes. With nickels, we could have quarters. And then with dimes, we could have dimes and quarters. Do you see that? And then with quarters, we have taken all of this, quarters and quarters. Let me push this bit, right? I hope that is visible now. So those are the possible combination of coins. Now, since we know that pennies means 0.1 cent, right? Just 0.01 cents. Nickels means 0.05. I should not write cents here now. Okay, let's write in cents. Sorry. So pennies means 1 cent. Nickels means, I was writing dollars. 5 cents. Dimes means 10 cents. And quarters means 25 cents. So if you add, what do you get? This is 2, right? 2 cents. This is 5 and 1, 6 cents. 1 and 10, 11 cents. 25 and 1 is 26 cents. Nickel and nickel means 5 plus 5, 10 cents. Nickel and dime means 10 and 5, 15 cents. 25 and 5 is 30 cents. This is 20 cents. And then we have this is 35 cents. And this is 50 cents. So we get this table which gives you total amount, correct? This says how many outcomes are possible. So these are the number of outcomes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how many outcomes are possible? So this number is 10 for you. Is it okay? How many combinations will add up to 20 cents? Up to means, add up to means, it is 20 or less. And then we need probability of having more than 20 cents. So which are more than 20 cents? Let's circle which are more than out of, we have total, let me rewrite now here. So total combination outcomes equals to 10. We just counted, right? Now up to 20 cents, that means less than or equal to, right? So let's see. And greater than, let's write greater than or equal to 20 cents. What is the probability of having more than? So we are only interested in greater than 20 cents. Okay. Up to 20 cents, let's circle those which are up to. So 1, 2, 3, 4, 5, 6 combinations. So up to 20 cents is 6. Okay. So that means including 20 cents. Greater than 20 cents are 1, 2, 3, 4. Well, that adds to total of 10. That's correct. Now the last question here is, what is the probability of having more than 20 cents? More than 20 cents. So greater than 20 is 4 out of total of 10. So that is the probability. So you can simplify this dividing both by 2. So we get 2 over 5. So our answer is 2 over 5, or in percent we'll do 4 over 10 times 100, which is 40%. Is that okay? So that is how you can organize your data and find probability. So in this set of questions which we answered, you learn a very important concept, and that is how to organize data, think logically, and then find probability. I hope you enjoyed this journey. Feel free to share your comments and views, and if you like and subscribe my videos, that'd be good for me. Thank you and all the best.